Hi everyone, my name is Amirani and I will be presenting today on Chlamydia trachomatis and Chlamydia muridarum. We're going to be focusing on the host's innate immune response after infection and the adaptive immune response after immunization. This figure was taken directly from the Centers for Disease Control and Prevention. It is a contrast of reported chlamydia cases between genders and age group. Male cases are on the left and female cases are on the right. It is interesting to see the pattern in both genders. At a young age, the reported cases of chlamydia are very low. As we hit our mid-teen years, the numbers of reported chlamydia cases increase drastically. After the teenage years, we see that both genders in the age group from 20 to 24 experience the highest rates of chlamydia. After that age, the reported cases begin to decline. This information is important when developing recommended vaccine schedules. For example, Gardasil, a vaccine that protects against sexually transmitted infection, HPV, is recommended to be administered before the age of 26, when the rate of infection is at its highest. What we know is that Chlamydia trachomatis is a bacterium that causes chlamydia, as well targets the reproductive tract to reproduce. Chlamydia is the most ubiquitous sexually transmitted disease in the United States, and a big part of that is because it goes asymptomatic, meaning after a person is infected, they show no signs or symptoms, therefore, they don't seek medical help to treat the infection. The longer the infection is untreated, the odds of becoming infertile rise, and in recent studies, it is seen that contracting HIV becomes more facile. It is important to differentiate between Chlamydia trachomatis, or CT, and Chlamydia muridarum, or CM. Chlamydia trachomatis naturally only infects humans, whereas CM naturally infects only members of the family Muridae. Thus, we are studying CM in mice as it has similar pathological tendencies to CT. What you're seeing here is the first 24 days of infection. The black bars represent wild-type mice, and the gray bars represent TLR3 knockout mice. We are seeing that mice with a TLR3 deficiency tend to have more oviduct shedding. This is an important finding as it helps us piece together how CM develops. We now know that the absence of TLR3 allows CM to reproduce and spread more easily. Oviduct shedding. So I keep talking about toll-like receptor 3 deficient mice having more oviduct shedding than mice with toll-like receptor 3 present. So what exactly is oviduct shedding? Shedding is the act of pushing out bacteria from the reproductive tract. The more shedding that there is, the more bacteria is being pushed out, causing the spread of infection. In our case, we're referring to CM. Back to how toll-like receptors work, they acknowledge proteins or molecules that have already been identified in pathogenic cells. Then, toll-like receptors, such as toll-like receptor 3, can go out and find double-stranded RNA to initiate apoptosis. Currently, we have no findings of double-stranded RNA in CM, but there is a reduced level of toll-like receptor 3 in mice that contract CM. Toll-like receptor 3 plays a vital role in weakening the development of CM, as toll-like receptor 3 knockout mice have shown to secrete interferon beta, interleukin 10, and interleukin 6. It is also notable that a reduction of toll-like receptor 3 reduces the synthesis of interferon beta. A present toll-like receptor 3 will initiate an immune response through the secretion of interferon beta. To measure, visualize, and monitor the cytokines secreted, IL-10, interferon beta, and IL-6, we used an enzyme-linked immunosorbent assay referred to as ELISA. ELISA consists of a plate covered in antibodies that will bind to IL-10, interferon beta, and IL-6. The bound cytokines will then become bound by antibodies that have fluorescent markers for the target protein. We use the fluorescent markers to monitor the presence of the cytokines. The absence of toll-like receptor 3 allows CM to thrive, but is not the only factor that allows CM to continue developing unnoticed. Cytokine secretions that are altered may also play a role in the development of CM. Mice with absent toll-like receptor 3 will decrease the amount of interleukin-6 that is secreted. This is a bad thing because interleukin-6 is a pro-inflammatory cytokine. When CM infects the mouse, we want a lot of pro-inflammatory cytokines to cause inflammation and alert other cells of the CM to activate an immune response. Low interleukin-6 means it will be less likely that an immune response will be activated and CM may go unnoticed. With interleukin-10, it is the opposite. It increases when the mouse is toll-like receptor 3 deficient. IL-10 is an anti-inflammatory cytokine, so an increase in interleukin-10 means less inflammation at the site of infection. This allows CM to reproduce and grow without causing inflammation that could trigger an immune response. That was a lot of information, so back to the basics of what we actually know. We know that toll-like receptor 3 is absent in mice that are infected with CM. We know that IL-10 and IL-6 are altered. Interleukin-10 is increased while interleukin-6 is decreased. We need interleukin-6 to activate an immune response. Therefore, it is not beneficial to us when IL-6 is low. We need low IL-10 so inflammation can take place and trigger other cells to respond. What we're seeing now is the opposite. So on to the CT vaccine and the role of Th17. Chlamydia can be problematic, and these problems can easily be resolved by a CT vaccine. The vaccine should be able to trigger and circulate memory T cells to the reproductive tract after the host has been infected. Th17 responses are vital as they provide protection to the host by inducing cells to secrete specific cytokines that are pro-inflammatory and can activate the immune response or apoptose infected cells. Not only that, but it can drastically lower the amount of present bacteria after infection in comparison to an unvaccinated host. Through the activation marker CD44, we can characterize pro-inflammatory cells that are responsible for clearing chlamydia. The vaccine should recruit Th17 cells, which will induce secretion of multiple cytokines, those cytokines being interferon gamma, IL-2, and TNF-alpha. Here, we are specifically comparing IL-17 positive CD4 T cells that secrete other cytokines. IL-17 is a pro-inflammatory cytokine that is essential for the host's defense against bacteria. We need interferon gamma to mediate the Th1 response, while TNF-alpha causes apoptosis of the infected cells. IL-2 is a necessary cytokine as it's pro-inflammatory and it's secreted by Th1 cells to activate T cells and produce TNF-alpha and interferon gamma. The goal is for Th17 T cells to recruit pro-inflammatory cells and get activated in the genital tract. In the figure below, infected mice are characterized by a positive sign. Non-infected mice are characterized by a negative sign. Immunized mice are characterized by a positive sign, and non-immunized mice are characterized by a negative sign. Here we see that immunized mice that are introduced to CM produce more cytokine-positive CD4 T cells, being interferon gamma, interleukin-2, interleukin-17, and or TNF-alpha, than infected mice without a vaccine. The vaccine allows for a higher response of CD4 T cells, allowing for a quicker immune response, leading CM to be cleared from the reproductive tract. Bacterial burden, or bacterial load, on non-vaccinated, vaccinated, and naive mice are quantified by inclusion-forming units, or IFUs, measured by log. It is shown that non-vaccinated mice have higher bacterial loads 7 days post-infection when compared to vaccinated mice. Vaccinated mice have activated immune responses with increased positive CD4 T cells that are reducing CM in the reproductive tract. The functionality and effectiveness of the vaccine is supported throughout my slides. In this slide, I show the most impacting for those of you who need visualization. The control uterine horns on section A are of non-infected mice. They showed nearly symmetrical structures. Section B is from non-vaccinated mice that have been infected. You can see the uterine horns are completely unsymmetrical. As well, there's enlargement and deformation. Section C is from the mice that have been vaccinated and are infected. There is nearly no change in the uterine horns when compared to the naive mice. Vaccination prevents histopathological changes to the reproductive organs when infected with C. Overall, mice vaccinated against chlamydia had a quicker response to CT because of the quick recruitment of Th17 cells. Chlamydia is able to reproduce more facile in mice with the absence of toll-like receptor 3 in oviduct epithelial cells. The absence of toll-like receptor 3 has shown to interact with specific interleukins such as interleukin 6. Toll-like receptor 3 has no effect on other interleukins such as interleukin 10. The contrast between interleukin 6 and interleukin 10 leave the question of how immune responses are initiated when chlamydia interrelates with toll-like receptor 3. Without vaccination, reproductive organs experience severe tissue damage. Uterine horns of vaccinated mice show less pathological changes when exposed to infection than non-vaccinated mice exposed to infection. The non-mucosal vaccine provides defenses that are enough to shield the host from not only infection, but pathology. For the questions, I'm providing graphs from a slide I previously showed. On the left-hand side, you have interleukin 6, and on the right-hand side, you have interleukin 10. Remember, interleukin 6 is a pro-inflammatory cytokine, whereas interleukin 10 is an anti-inflammatory cytokine. The absence of toll-like receptor 3 may be responsible for chlamydia thriving as it interacts with what interleukin, causing a decrease of activated immune responses. Furthermore, what toll-like receptor plays a vital role in weakening the development of C. muridarum?